Today's topic is one that almost everyone working with data has heard of, but few people actually understand. Microsoft Fabric OneLake. You've probably seen it in Microsoft's marketing or heard someone call it the unified data lake for your entire organization. But what does that actually mean? Is it just another storage bucket or is it something fundamentally different? Here's the simplest definition. OneLake is a single logical data lake that sits at the center of Microsoft Fabric. Every Fabric service, Lakehouse, Warehouse, Event House, Power BI, stores its data here. And the key rule is simple. One physical copy of data, accessible by many different engines. No more copying data from one tool to another. No more wondering which version of a report is correct. By the end of this episode, you'll understand what OneLake actually is, how it eliminates data duplication, and why it changes the game for Power BI, data engineering, and AI. So let's start with the problem OneLake was built to solve. The problem: every department has its own lake. Imagine you work at a mid-sized company. Your sales team uses a CRM system to track deals. Your finance team runs the ERP for billing and invoices. Your marketing team pulls data from their campaign tools. And your data engineering team manages a data warehouse for reporting. So here's what I want you to think about. How many copies of the same customer data exist across these systems? In most companies, the answer is 4 or 5. The CRM stores it. The ERP stores it. Marketing exports it into their analytics tool. Someone in finance builds a spreadsheet from the ERP. And the data engineering team copies it into the warehouse so Power BI can read it. That's the same customer ID, the same sales amount, the same invoice date, stored in 5 different places. This isn't because people are careless, it's because the old tools didn't talk to each other. If you wanted to run a report that combined sales data from the CRM with financial data from the ERP, you had to copy both into something that could read them together. That meant building pipelines, scheduling jobs, and hoping nothing broke overnight. The hidden costs add up fast. Storage bills grow because you're paying for the same data 5 times. Reports go stale because one copy gets updated while another doesn't. And then someone asks the question nobody wants to answer: which version is the right one? That confusion erodes trust in data. And once trust is gone, people stop using the analytics platform altogether. So Microsoft looked at this mess and asked a simple question: what if you could have one copy of your data that every tool could read? No duplication, no confusion. One source of truth. What exactly is OneLake? OneLake is Microsoft's answer to that question. It's a single, logical data lake for your entire organization. The key phrase to remember is this: one lake per tenant, not one lake per team. Under the hood, OneLake is built on Azure Data Lake Storage Gen 2. Same technology, same APIs. But Microsoft has repackaged it as a fully managed SaaS service. You don't create storage accounts. You don't manage containers. You don't set up access keys. You just use it. Think of it like OneDrive for your company's data. OneDrive gives you one place for your personal files, documents, photos, spreadsheets. You don't think about where they're physically stored. You just open them and work. OneLake does the same thing, but for your organization's data. It gives every team, every project, every workload one shared pool of storage. Now, here's an important distinction. OneLake is logical, not physical. Under the hood, it can span multiple storage accounts across different regions. But to you, it looks like one giant pool. You don't care which server holds the files. You just see your data. Every Fabric service stores its data here. When you create a lakehouse, the data lives in OneLake. When you build a warehouse, the tables live in OneLake. When you run a Power BI report, if it uses Direct Lake mode, it reads directly from OneLake. Even Event House, the real-time analytics store, can expose its data into OneLake. Everything points to the same place, and the default data format is Delta Parquet. That's an open format, not a Microsoft lock-in. Databricks uses it. Spark engines read it. Tools like Pandas and Polars can work with it. So your data isn't trapped inside Microsoft's world. It's open and portable, but the real magic isn't storage. It's how OneLake eliminates the need to copy data in the first place. The one-copy principle. Now here's the core idea that makes OneLake different from anything that came before. It's called the one-copy principle. And it's simple. One physical copy of data, accessible by many different engines. Let me show you what that means in practice. Say you have a table of sales data sitting in OneLake. A data engineer runs a Spark notebook to clean it. A business analyst writes a T-SQL query to aggregate it. And a Power BI report reads it for a dashboard. All 3 happen at the same time. All 3 read the same file. Nobody copied anything. In the old world, that never happened. You'd copy data from the data lake into a warehouse. Then you'd copy it from the warehouse into a semantic model. Then you'd refresh the report. That's 3 copies of the same data, each one taking time and storage space. And if any step failed, your numbers were wrong. One copy eliminates all of that. The data sits in OneLake once. The engines, Spark, SQL, Power BI, all read it directly. No movement, no duplication, no synchronization issues. The cost savings are real. Less storage because you're not paying for the same data 5 times. Less ETL because you're not building pipelines just to move data between tools. Fewer things to maintain because there's nothing to break between copies. And the freshness benefit is huge. One copy means one source of truth. When the data updates, every report sees the update immediately. No more asking, is this report using last week's data or this week's? It's always the same data everywhere. Now, you might be thinking, well, isn't this just Azure Data Lake storage? Not exactly. ADLS is a PaaS service. You create storage accounts, you manage containers, you set up access keys, you decide which region holds what. It's flexible, but it's also work. OneLake is a SaaS service. You don't create storage accounts, you don't manage containers, you just use it. The underlying infrastructure is handled for you. One copy is great for data that lives inside Fabric. But what about data that lives somewhere else? Shortcuts. Leave the data where it lives. So this is where shortcuts come in. A shortcut is a virtual pointer. Think of it like a symbolic link for your data lake, and it lets you access data that physically lives outside OneLake without moving or copying it. Here's how it works. You create a shortcut inside a lakehouse or a warehouse, and that shortcut points to a file or folder somewhere else. Could be in an Azure Data Lake storage account, an Amazon S3 bucket, Google Cloud Storage, or even another Fabric workspace. The data stays where it is, but from inside Fabric, it looks like it's right there in OneLake. Let me give you a real scenario. Your sales team has been running their analytics on AWS for years, so all their data sits in S3 buckets. Your finance team uses Fabric and Power BI, and they need to combine sales data with financial data. In the old world, you'd export everything from S3, upload it to Azure, build a pipeline to keep it in sync, and hope nothing broke. With shortcuts, you create a shortcut from your Lakehouse to the S3 bucket. The data stays in AWS, but finance can query it in Power BI like it's sitting in OneLake. No export, no upload, no pipeline to worry about. Shortcuts work internally too. If one team has a curated dataset in their workspace, another team can create a shortcut to it. No copying, no duplication. The data stays in the original workspace, and everyone else just references it. There's one limitation you need to understand. Shortcuts don't copy data, so query performance depends on the source system's speed. If you're shortcutting to an S3 bucket on the other side of the world, your queries will be slower than if the data was local. For frequently accessed data, consider mirroring it instead. And that brings us to our next topic. Mirroring automatically bring in database data. Shortcuts cover external file storage really well, but what about your existing databases? The ones running your ERP, your CRM, your operational applications? That's where mirroring comes in. Mirroring is a way to get data from databases into OneLake in near real time without building a single pipeline. You point Fabric at your database, and it handles the rest by creating an automatic incremental copy of the data into Delta Parquet format inside OneLake, keeping that copy up to date as changes happen in the source. The supported sources include Azure SQL Database, SQL Server running on-premises, Cosmos DB and others, and Microsoft is adding more over time. But the most common scenario is your business-critical database, the one your ERP runs on or your line of business application. Here's how it works. You enable mirroring on a database, and Fabric reads the change feed, inserts, updates, deletes, and replicates those changes into OneLake. The first sync copies the full dataset. After that, it's incremental, only moving the changed rows. The data lands in Delta Parquet format, ready to be queried by any Fabric engine. Now here's the key difference from shortcuts. Shortcuts don't copy data, they point to it. Mirroring actually copies the data, so the data lives in OneLake physically, and query performance is fast regardless of how fast or slow the source database is. The trade-off is you're storing a copy, but the benefit is near real-time access with no pipeline to build, no scheduling to manage, and no maintenance to worry about. Let me give you a concrete use case. Your company runs an ERP on SQL Server, and it holds all your financial data: invoices, payments, general ledger. In the old world, you'd build an ETL job that runs every night, extracts the data, transforms it, and loads it into a warehouse. That job breaks, someone has to fix it, and the data is always at least a day old. With mirroring, you enable it once, and Fabric replicates the data into OneLake continuously. Your Power BI reports read directly from OneLake and see data that's minutes old, not hours or days, and you never touched a pipeline. Now you have data in OneLake from shortcuts, from mirroring, and from direct uploads. How do you actually use it? OneLake and the 3 data stores. So OneLake is the storage layer, the place where all your files live. But here's the thing, you don't actually work with OneLake directly. Instead, you interact with it through what we call data stores, which are interfaces that give you different ways to work with the same underlying data. There are 3 main data stores in Fabric: Lakehouse, Warehouse, and EventHouse. They all store their data in the same OneLake, but each one serves a different purpose. Let's start with Lakehouse, the flexible data store that accepts files like CSV, JSON, and images, along with Delta tables. You use it when you're doing data engineering, machine learning, or landing raw data from source systems. It's a workbench where you clean, transform, and prepare data. If you're building a medallion architecture with bronze, silver, and gold layers, the Lakehouse is where that happens. You can access it through Spark notebooks or through the SQL Analytics endpoint for read-only queries. Next is Warehouse, the structured data store. It gives you full T-SQL read and write support, so you can create tables, views, stored procedures, and functions, and run insert, update, delete statements. It feels like a traditional SQL Server database because it's designed for people who think in SQL. Use warehouse when you're building BI reports, running complex aggregations, or migrating from an existing data warehouse. Think of it as the gold layer for enterprise reporting. Then there's Event House, the real-time data store built on the Custo engine, the same technology behind Azure Data Explorer. It handles streaming data, logs, IoT telemetry, and clickstreams, anything that arrives fast and needs to be queried immediately. You query it with KQL, the Custo query language. And when you enable OneLake availability, that event data becomes accessible to Lakehouse and Warehouse as Delta tables. So here's what you need to understand. All three store their data in the same OneLake. A table created in a Lakehouse can be read by a Warehouse query. A table in a Warehouse can be accessed from a Spark notebook. Data ingested into Event House can be exposed as Delta tables for Power BI. They're not separate databases, they're different views into the same data lake. A lot of people get this wrong. They think Lakehouse, Warehouse, and Event House are competing products, but they're not. You actually use all three because each one solves a different problem. Lakehouse for data engineering, Warehouse for BI, Event House for real-time, and they all share the same storage. OneLake handles the storage, and the data stores handle the access. But who gets to see what? Security and governance in OneLake. Because all your data lives in one place, security becomes simpler. You manage access in one spot instead of across 10 different systems. No more setting permissions in the CRM, then again in the warehouse, then again in Power BI. OneLake gives you a single security model for everything. At the top level, you have workspace roles: admin, member, contributor, viewer. These control who can work in a given workspace. If someone is a viewer, they can see items but not modify them. If they're an admin, they control everything. Simple enough. But you can take it further. OneLake security roles let you control access at the folder level, the table level, the column level, and even the row level. For example, column level security means you can hide salary information from everyone except HR. Row level security means a sales manager only sees their own region's data. And it works the same way across all the data stores because they all sit on the same OneLake. There's also the OneLake catalog, a central view where you can see all data across all workspaces. You can find certified data sets, check who owns what, and manage governance from one place. It integrates with Microsoft Purview for classification, sensitivity labels, and data loss prevention. So if you need to mark certain data as confidential or highly restricted, you can do that at the lake level, and it applies everywhere. And there's OneLake Diagnostics, which captures who accessed what and when. It's useful for audits, compliance checks, and answering the question, who touched this data last week? It logs every read and write operation and stores those logs as JSON files inside a lakehouse. You can analyze them with Spark, SQL, or Power BI. The big picture is this: one security model for all your data, instead of managing separate rules for every tool. That's a massive simplification for any organization. Practical takeaways, what this means for you. So what does all this actually mean if you're starting your Fabric journey today? Let's break it down. If you're building a new data platform, OneLake removes the need to architect complex data movement. You don't have to plan how data flows from a lake into a warehouse into a semantic model. Just put it in OneLake and every tool reads from there. One lake, one copy. That's the whole architecture. If you're migrating from an older system, shortcuts and mirroring let you leave data where it is while gradually shifting workloads. No big bang migration needed. Point a shortcut at your existing data lake, mirror your SQL Server database. Start using Fabric while your old systems keep ticking along. You move at your own pace. Here's the mindset shift. Stop thinking about storage per project. Stop creating a new data lake for every new initiative. Start thinking about one shared lake that every project accesses. Your sales team's data, your finance team's data, your engineering team's data. It all lives in the same place. They just see different parts of it. For Power BI users, reports read directly from OneLake. No separate import, no duplicated semantic models. The data is fresh because it's the same data the data engineers work with. For data engineers, that means fewer pipelines to build, maintain, and debug. You land the data once. Everyone else just references it. The bottom line is this: OneLake isn't just another data lake. It's the foundation that makes Fabric different from anything before it. It's the reason you can stop copying data and start trusting it. So there you have it. OneLake is your organization's single data lake built on the one copy principle. One physical copy of data, accessible by any tool, any team, any workload. No more duplication, no more confusion about which version is correct. Your homework is simple. Start with a shortcut from an external source or mirror a database. See how simple it becomes when you don't have to build pipelines just to move data around. Most organizations won't make this shift quickly. Be the one that does. If this episode helped you understand OneLake, subscribe to Microsoft Knowledge Nuggets for more Fabric content in plain English. And share this with someone who's still managing 5 separate data lakes. They'll thank you later.